integration of rational functions by partial fractions. Alright, so before we can actually talk about partial fractions, let's talk about integrals that involve quadratics of the form ax squared plus bx plus c. Let's recall completing the square. You learned this when you learned how to do the quadratic formula. And the goal in completing the square is to rewrite ax squared plus bx plus c in the form a times x minus h squared plus k. And the reason you want to do this is once you did this, hk, the point h comma k, is the vertex of your parabola. This is also how we came up with our quadratic formula. So let's remember how we did it. We start out with ax squared plus bx plus c, and then we factor out an a from the first two terms. So that becomes a times x squared plus b over a times x. And then I still have that plus c hanging out there. Now what I really want to do is take what's in the parentheses here and make that a perfect square somehow. And the way to do that is to take the coefficient of x here, so the b over a, and add half of that squared inside my parentheses. So right here I take half of the b over a and I square it. Now since I added it here, I need to make sure I take it away so that I don't change my equation, so that I'm essentially adding 0. So here I'm going to subtract it off, but don't forget it's being multiplied by this a here, so that's why there's an a there. Alright, so now that we've done that, this term in the parentheses, the big parentheses, that can be written as x plus b over a squared. And here is how we write it in terms of a times x minus h squared plus k. Here our h is equal to the negative b over 2a, and our k is equal to c minus b squared over 4a. Alright, so once we know how to complete the square, what we're going to do is take this, and if we want to integrate an expression involving ax squared plus bx plus c, we're going to make the substitution of u is equal to x plus b over 2a, so that I can rewrite ax squared plus bx plus c as a times u squared plus d, where that d is equal to the constant at the end, which is c minus b squared over 4a. Alright, so let's see how this is going to work. In this example, let's integrate 1 over x squared minus 2x plus 5. So the first thing we're going to do is we're going to complete the square of x squared minus 2x plus 5. So to do that, I take this negative 2 and I add on half of that squared. So half of negative 2 is negative 1. When I square it, I get 1. So I'm going to add on 1 here. And since I'm adding it in, I need to make sure I take it away so that I'm only adding 0 to my equation. Now I can rewrite the part in the parentheses as x minus 1 all squared, and 5 minus 1 is equal to 4. Alright, so that makes my integral of 1 over x squared minus 2x plus 5 equal to the integral of 1 over x minus 1 squared plus 4. So now I'm going to make a u substitution of u is equal to x minus 1, which means du is equal to dx, so that my integral now becomes the integral of 1 over u squared plus 4. Now this should put in your mind tangent inverse, because the derivative of tangent inverse is 1 over 1 plus x squared. So it looks very similar to this, except instead of a 1, like down here, I have a 4. So the way that we're going to take care of that is I'm going to factor out a 4 from the denominator. And then, what do I want? To make it look like this, I need it to be at the form 1 plus something squared. And right now I have 1 plus something squared divided by 4. That's not going to work. So I'm going to take that and rewrite it as u over 2 all squared. So now I can say, okay, let's make a well, we don't even need to make a substitution. We should be able to see that now the antiderivative of 1 over u over 2 squared plus 1 is going to be equal to tangent inverse of that u over 2. I'm going to need to multiply by the reciprocal of the constant 1/2, so there's my 2. And now we've found our antiderivative. Well, we're not quite done yet. It's still in terms of u. I need to put it back in terms of x. We said that u was equal to x minus 1, so we get our final answer. All right, let's try another one. Evaluate the integral of x over x squared minus 4x plus 8. So the first thing we're going to do is complete the square of x squared minus 4x plus 8. To do that, I take the x squared minus 4x, put them inside the parentheses, and then I'm going to add on half of this term right here, the coefficient of x. So half of negative 4 is negative 2, and then square it. Negative 2 squared is 4. So I'm going to add 4 on here, and since I add it on, I have to take it away. What's inside my parentheses now becomes x minus 2 quantity squared, and then 8 minus 4 is 4. So that tells me that my integral of x over x squared minus 4x plus 8 is equal to my integral of x over x minus 2 squared plus 4. So now we go ahead and make a u substitution of u is equal to x minus 2, which also means that u plus 2 is equal to x, and that du is equal to dx. Now if we make our substitution in, we said that x was going to be equal to u plus 2, dx is equal to du, x minus 2 is equal to u, so we get the integral of u plus 2 over u squared plus 4 du. Alright, so looking at that, how are we going to evaluate this integral? Well, I can't make another substitution because if I let like v be equal to u squared plus 4, the antiderivative would be, the derivative would be 2u du. Where's that plus 2? It's not showing up. Well, we can take care of this by breaking this up into two fractions and saying this integral is equal to the integral of u over u squared plus 4 plus the integral of 2 over u squared plus 4. Now, the second integral there should look familiar because from example 1, we know that the integral of 1 over u squared plus 4 is equal to 1/2 tangent inverse of u over 2 plus c. So using this, we can get that the integral we had is equal to, well, I'm not going to do anything in my first integral yet, but it's going to be equal to that plus 2 times 1/2 tangent inverse of u over 2. All right. So now we need to find this integral. And here now we can go ahead and make another substitution. We'll let v be equal to u squared plus 4, which tells me that dv is equal to 2u du, or that 1/2 dv is equal to u du. We go ahead and make our substitutions just into the integral part, and we get that that becomes the integral, well, 1 over u squared plus 4 is v, and then the u du is the 1/2 dv. And then I'm still plus what I have left here, which is tangent inverse of u over 2. Now to evaluate this indefinite integral here, well, that's going to be 1/2 times the natural log of v. Don't forget your absolute value signs. And then we're not doing anything here, so we just add on tangent inverse of u over 2, and now we need a plus c. And we're almost done. The only problem is we started out with x's, and right now our answer's in terms of u's and v's. We need to get rid of them. So v was the last substitution we made, so let's go ahead and substitute back in for our v. And that gives us that our answer is equal to 1/2 times the natural log of u squared plus 4 plus tangent inverse of u over 2 plus c. And now we can go ahead and substitute in what we know u is equal to. We said u was equal to x minus 2. We substitute that in to get our final answer. All right, let's try one more. Let's evaluate the integral of 1 over the square root of 5 minus 4x minus 2x squared. Oh, this should be interesting. I have a square root there. Well, let's start the way we've been doing it. Let's go ahead and complete the square. Rewriting 5 minus 4x minus 2x squared as minus 2x squared minus 4x plus 5. To complete the square, the first thing we do is we factor out the negative 2 to get x squared plus 2x inside my parentheses, and I leave that 5 out there. And then I take half of the coefficient in front of x, which is 1, and square it, which gives me 1, and I add that on inside my parentheses. Now remember, when I add something on, I need to subtract off the same amount so that I'm not changing my equation. Well, I didn't just add on 1, I added on 1 times this negative 2 here. So that gives me a negative 2. That means I have to add on 2 to cancel it out. So now, just rewriting this as negative 2 times x plus 1 squared plus 7, we can now say that the integral we were concerned about is equal to the integral of 1 over the square root of negative 2 times x plus 1 squared plus 7. All right. Now, what did we do next? The next thing we did is we made a substitution. We let u be equal to x plus 1. That means du is equal to dx. So my integral now becomes the integral of 1 over the square root of negative 2u squared plus 7. Or just switching the order here, it's the integral of 1 over the square root of 7 minus 2u squared. Now, to evaluate this integral, you should be thinking to yourself, I bet this has an inverse trig function in there. Now the question is which one? Well, the one we want to use is sine inverse, because the derivative of sine inverse is 1 over the square root of 1 minus x squared, so a constant minus something squared, which is what we have here. So to make it look like this, I need it to be 1 minus something squared. So I'm going to get rid of this 7 by factoring it out. And now I need it to be under here of the form 1 minus something squared. So I'm going to rewrite 2 over 7 times u squared as the square root of 2 over 7 times u all squared. So now that I've done that, I can say, okay, that's going to be equal to 1 over the square root of 7 here times the antiderivative, which gives me sine inverse of the square root of 2 over 7 times u, multiply it by that reciprocal of the constant, the square root of 2 over 7 here, plus c. And our last thing to do is simplify here and replace our u's with expressions in x. So this becomes 1 over the square root of 2 times sine inverse of the square root of 2 over 7 times x plus 1 plus c.